Good morning everyone, how's it going today? Welcome to this week's new video tutorial in which I'm going to be showing you how to use Qdrant. Now Qdrant is a vector database that is an alternative, an open source alternative to Pinecone, and they also have a managed cloud service. In this video I am going to show you how to set up and configure a free forever 1 GB cluster in their cloud service and how to use it to connect it to your application. Okay, this is especially useful if you want to have a language model application that has its vector database persisting over time, and you want to store that database in the cloud and you don't want to deal with all the configuration of the servers and all that. It's basically going to allow you to have your database available from a URL, and you're going to be able to fetch all the information from there with just Qdrant's API. Okay. In most of the videos from this channel, we have created applications that don't necessarily have a persistent database, so this is going to be a complement to all of those videos. So by the end of this video, you will have something like this, and you will be able to query it with information that is already inside the database without actually having to rerun the embeddings every time that the application loads. Okay, so there you go. I hope that by the video you will have a very robust project that you will be able to showcase to your clients, employers, or future employers, and you will be able to add this to your portfolio. I hope that you enjoy, and remember that if you like AI and software videos, don't forget to subscribe. Alright, so without further ado, let's get right into the video. Alright, so the first thing that we're going to want to do is we're going to want to create an account in Qdrant's cloud platform. Okay, in order to do that, you're going to want to go to qdrant.tech, and then you're going to want to click right here on cloud, and it's going to ask you to create an account. I'm going to set up mine with GitHub. I have already created my account, which is going to connect, but you will probably have to create your account first. And once your account is created, you will be greeted with this page right here, which prompts you to create your first cluster. Okay. Now, in order to create the first cluster, you can either just give it a name if you don't want to personalize it, or you can create a custom tier cluster, which can also be free. Okay. I'm going to create a custom one. I'm going to call it my cluster. And something interesting about this one is that you can choose the region where your servers are going to be located. So myself, I'm going to set it up in Europe, and as you can see, we're still inside the free tier pricing. As I mentioned before, you have a free 1 GB of memory. If you want to increase it, you're going to have to pay for it, but you can leave it free here, and there you go. Now we can create the cluster, and it's going to take a little bit of time initializing it and mounting it. So I'll be back once this is done. It should take a few minutes. And there we go. Now our cluster is healthy and ready to be used. As you can see right here, we have in the configuration, we have a 1 GB of RAM, we have half a virtual CPU and 20 GB of disk space, which should be more than enough for any testing that you want to do, or maybe even for a very small scale production application. Okay. Now what we're going to do is we're going to go back to overview, and as you can see, the next step after setting up the cluster is creating an API key to connect to that cluster. Okay, so that's what we're going to do. If you had several clusters, you're going to want to select the one that you want the API key from right here, and then you can click on Get API Key. Here, this is the API key that I'm going to be copying, and I'm going to paste it right here in my notebook, and then we can just continue, and you can see that this is the curl command that you can use to access your cluster. Okay, so now let's start interacting with our cluster through this endpoint. All right, so let's do that now. All right, so now the next step to take is to start testing our cluster. Okay. Once you create your cluster, you get a URL, which is the one that you're going to be using to send requests in order to interact with your cluster. Okay. So for example, if you want to create new vectors or if you want to store something, or if you want to fetch the vectors that you have stored in a collection, this is the URL that you're going to be fetching them from. Okay. So the first thing that I recommend you to do is just like to get familiarized with how these things work, is to start testing it using a HTTP client. Okay. You can use Postman, for example, if you want, or you can use Thunder, which is a HTTP client for VS Code. It's very minimalistic, and I really like it. It's basically just like this. You create a new request, and right here you just write the URL that you want to send a HTTP request to. So I'm going to send it to my URL that I just created. And as you can see right here, they ask us to send the API key as a header. So I'm going to copy my API key. I'm going to go to headers. I'm going to say API key. I'm just going to paste it right here in the value. And there you go. So now this is going to allow us to send HTTP requests to my cluster. Okay. Now, before I show you some of the endpoints that you can use, let me just explain to you a little bit of how the architecture of Qdrant works. So in Qdrant, we just created a cluster, okay? And the cluster can have several collections. Collection, you can think of it as a database. So you create your cluster, then you can have several collections or several databases inside of your cluster, and each collection can contain one or more points. And each point is a vector, okay? And remember that a vector is just a numerical representation of your text. So whenever you embed your text and you send it to your database, that is going to be stored as points inside the collection that you specify. Okay. So the first thing that we're going to do is we're going to want to ask our host how many collections it has in the cluster. Okay. So in order to do that, we're going to come right here to the Qdrant documentation. And here you have an endpoint that lists all the collections. So you can see that it's a GET request that we send to collections. So I'm going to add slash right here and say collections. And I'm sending a GET request. My API key is here in the header. So if I send it, you can see that I get a response, 200, okay. And you can see that I get that the result is collections. It's an empty array, which means that there are no collections in this cluster, which makes sense because we just created it, okay. Now, if you wanted to create a collection using a HTTP client like this, you can send a put request to this endpoint right here. You just add the collection name, and then you just specify what specs you want your collection to have. But in our case, we're going to be creating our collection from a Python script so that we can implement it in our applications. Okay, so let's get right into doing that. All right, so what we're going to be doing now is I'm going to be showing you right here on a notebook how to create a client to interact with your host in Python, how to create a collection, and how to add points or vectors to that collection in your cluster. Okay, so first of all, what you're going to want to do is you're going to want to install the dependencies. In our case, we're going to be using Langchain, Qdrant, and OpenAI because those are the libraries that we had been using in the other videos of this playlist, so that we can actually implement this in one of the applications that we have built before. Next, let's actually start in importing our dependencies. So we're going to say that from Langchain.vectorstore, we're going to import Qdrant. And then from Langchain.embeddings.openai, we're going to import OpenAI embeddings, like that. Sorry, it's not vector store here, it's vector stores, like that. There you go. So then we're going to import Qdrant client, like that. And we're also going to import OS to use environment variables. There you go. There you go. So now the first thing that you're going to want to do is you're going to create a Qdrant client. Okay. So in order to do that, the first thing that I'm going to do is I'm going to store my host and my API key in some environment variables. Okay. So I'm going to say environ, and this one I'm going to call it Qdrant. Oops. I'm going to call it Qdrant host, and this one's going to be equal to my host URL right here, like that. Then I'm going to do the same, but Qdrant API key, like that, and the value for this one is going to be my API key, like that. There you go. Once that's done, what you're going to want to do is you're going to create your client. In my case, I'm just going to call it client like this. And in order to initialize it, this is going to be an object that is going to allow us to connect to our cluster. Okay, so what I'm going to do is I'm going to do Qdrant client like this, and then I'm going to initialize a Qdrant client like that. Now this one takes several parameters. The first one, as you can see, is the URL of your database. Okay, in our case it's our Qdrant host, so I'm going to just get the environment variable called Qdrant host like this, and then the API key is the second variable right here. I'm going to call it, I'm also going to do os.get env, and this one we're just going to get our Qdrant API key like that. Now if I run this, it should create my client object. There you go. Now we can use this client object to actually start creating collections and interacting with our cluster. Okay, so let's do that right now. Alright, so the second thing that we're going to want to do is to create a collection. Okay, remember that I told you that in Qdrant we just created a cluster, but we don't have any collections inside of it. A collection, remember, it's just a database with vectors. Alright, so we're going to create a collection using the client object that we initialized up here. So in order to do that, I'm just going to create collection right here. And the first thing I want to do is I want to set the name of the collection in an environment variable. This just makes it look closer to production. Okay, so I'm going to say os environ. So I'm just going to copy this up here like this, and it's going to be Qdrant collection name like this. And the collection name, you can name it whatever you want. Remember, we're just creating a new collection, so you can really name it whatever you want. In my case, I'm just going to call it my collection like that. And this name has to be unique, okay? You cannot create two collections in the same cluster with the same name. So there you go. Now we can use this client object to actually start initializing our new collection. In order to do that, I'm just going to come back here to the documentation of Qdrant. Inside concepts, I have collections, and here is the code for Python in order that we can use to create a collection. Just going to copy it right here. I don't need the client initialization because I just initialized it before. So I'm just going to copy this and paste it right here. Okay. As you can see, this one takes two different arguments, two different parameters. The first one is the collection name, and the second one is the vectors configuration, which I'm going to initialize up here. I'm just going to call it vectors configuration, like that. All right, so the collection name, we have already initialized it up here, so I'm just going to get the environment variable from there. Remember, this is how we call environment variables. And then the vector configuration is another object that we import from Qdrant. Okay, in this case, I think that they imported it from qdrantclient.http.models. So that's what I'm going to do. Since I already imported Qdrant client, I'm just going to call it directly from qdrantclient.http.models. There you go. And There you go. So now what we're doing right here is we're creating our vectors configuration object. As you can see, the first one is the size. The first parameter is the size of the vectors. This one right here takes the dimension of the vectors that are returned by your embeddings model. Okay. For example, OpenAI's embeddings return a model, return vectors with a dimension of 1536. If you're using, for example, instructor Excel, you're dealing with a dimension of 768. And these are things that you can just Google and you can just find out which dimension each embeddings model is going to be using. In our case, we're going to be using OpenAI's embeddings. So I'm going to be setting it to 1536. Let me just add this comment right here, just to indicate that for instructor Excel, it's 768. And then the second parameter is the distance. If you're not familiar with how NLP works, don't worry about this. You don't really need this to build an application. This is more if you're more into the data machine learning side of this. But the idea is that you want to tell Qdrant which distance metric it's going to be using to find the closest, to perform the similarity search. Okay. So in our case, we're going to be using cosine similarity. And as you can see right here, we're going to be, that's an object also in my Qdrant HTTP models. And there you go. So now this is the variable that I'm going to be adding to my vectors configuration parameter. And now when I do run this, you can see that I get a return message from the client, which means that the collection has been created. There you go. So now what we can do is we can go back here to our HTTP client, and in order to test that our collection has been correctly created, we just send the same request that we sent a moment ago. So remember, we keep the same host here, and remember that we want to hit the endpoint collections. Remember, API key, all is the same. You can also do this in Postman. I just like Thunder because I think it's just it's minimalist. And then if I send it, you can see that this time I get returned a list of collections, and this time it's not empty. This time we have one element with the name of my collection, which is precisely the collection that I created a moment ago. All right, so next thing we need to do is we need to create our vector store object, which is the one that we're going to be plugging into our application in order to interact with our collection. Okay, so in order to do that, we're going to be using the integration that Qdrant has right here. We're going to go to the documentation page, to integrations, and we had been using Langchain in the other video, so I'm going to show you how to do this in Langchain. In a future video, I'm going to show you how to do the same with Llama Index, which is also super powerful. And here you have the code that you need. As you can see, you need to create some embeddings. You need to define your client, which we already did, and then you need to initialize your document store or your vector store object. And this one uses a Qdrant class, which you import from Langchain vector stores. Here I noticed that I forgot, I think that I named mine with a lowercase q, so it's supposed to be uppercase. There you go. And now we can actually just copy this part right here, which is the one that we need in order to initialize our vector store object. Okay, so I'm just going to call it vector store like this. I'm going to be initializing it from Qdrant. It takes, as you can see, 3 different arguments. The first one is the client, which we already defined. The second one is the collection name, which we defined right here. I'm actually just going to use os get env, and I'm just going to paste this one right here. And then it requires the embeddings as well. So let me just initialize the embeddings. Embeddings is going to be the OpenAI embeddings that we imported up here. Remember that if you want to use a different embeddings model, you're going to have to change the size of the collection that you're using, because you cannot add instructor embeddings to a collection that was that also has OpenAI embeddings in it. Okay, so you're going to have to be consistent with the same embeddings model for each collection. So in this case, we're going to be using this collection, and the embeddings is initialized. And the OpenAI embeddings actually requires you to have an environment variable with the OpenAI key that you're going to be using. Okay, so in our case, I'm just going to come right here to my API keys in OpenAI. I'm going to create a new API key, copy. There you go. I'm going to come back here, and I'm going to initialize it like this. I'm going to do os.environ, and the name of the environment variable has to be OpenAI API key, otherwise Langchain will not recognize it. And there you go. Now this, if I'm not mistaken, should create the vector store object that we require. Just add a comment right here, create vector store. There you go. Now we have created our vector store, and now we can actually start adding vectors to this vector store in our application. So let's do that now. All right, so now that we have our vector store, we want to add some text to it, okay? Some vectors. In my case, I asked ChatGPT to create a very quick story about a few friends who find a fluffy dog on the street. And this is the story that I'm going to be feeding to my vector store and that I'm going to be querying. So I'm going to be asking questions about this story, and my application is going to be able to retrieve that from the database. Okay, so I already uploaded the story.txt file right here to my workspace, and that's where I'm going to be fetching it. So first, this cell is going to be titled add the documents to vector store, like this. So to do this, first of all, we're going to have to create a function that takes this huge string of text, and it's going to split it into shorter chunks of text, so that, remember that what we're going to want to do is we're going to fetch the chunks of text that are going to be relevant to our question. So we don't want to send like 10,000 characters to our language model, because we could very easily reach the token limit. So what we're going to do is we're going to take all of this huge text and we're going to split it into shorter chunks so that we can feed them to our language model. In order to do that, we're going to use Langchain's text splitter class called character text splitter. Let's see, there you go. And I'm going to define a function called getChunks, which is basically going to split my huge string of text into several chunks of smaller size. So this one was going to take a string of text. I'm going to initialize my object called text splitter, and I'm going to use my class that I imported. Now this one takes several parameters. The first one is my separator, which is the character that is going to define the line break. In my case, it's just one line. And then we're going to have to define the chunk size. And in this case, the chunk size is going to be 1,000 characters. This means that it's going to return different chunks of 1,000 characters each. Then the other parameters is the chunk overlap, which means, this 1,000 is not supposed to be a string, it's supposed to be a number, like that. The chunk overlap is the overlap for each chunk size, okay? So for example, if the first chunk goes from the character 0 to the character 1,000, if I set an overlap of 200, the second chunk is not going to start at the character 1,001, but on the character 1,000 minus 200. So it's going to start at the character 800. So the first chunk is going to be 0 to 1000, and the second one is going to be 800 to 1800. This basically allows us to get more context into each one of our chunks of text, because if we split our text like arbitrarily at the character 1000, we might fall in the middle of a sentence and we will lose the sense of that sentence into different chunks. So that's basically how this works. And last but not least, the length function that we want our text splitter to use to measure the text. In this case, we're just going to use regular Python length function. And then with this, what we're going to do is we're going to create a new chunks array, which is going to take my object that I just created. And this one has a method called split text. And this one's going to take my string of text that I'm going to feed my function. Then we're just going to return the chunks of text. So in short, this function is going to be returning an array of short chunks of text that have been, it's going to return this text split into different chunks. Okay, there we go. Now what we're going to do is we're going to use this function to split my story. So what I'm going to do is I'm going to say that my texts are going to come from, well, first of all, I have to open my story. So I'm going to do with open story.txt, like that. As file, we're going to say that raw text is going to be f.read. There you go, my file.read. This means that inside this variable, I have all these contents right here. Okay, all the contents of my story are now in my raw text variable. So now what I'm going to do is I'm going to take these texts, I'm going to take my raw text and I'm going to divide it into different chunks of text with my function getChunks. So in order to do that, I'm just going to call getChunks. And I'm going to pass in my raw text function like this. And now that I have my text function right here, let me just show you what it looks like. If I print it, and I have an error, length function, length function. Nope, not like that. Length functions written like that. There you go. So now you have an array with a bunch of chunks of text, each one 1000 character long, and each one has part of this story right here. And now from this text, these are the ones that we're going to embed using OpenAI embeddings and store them in my vector store. So in order to do that, I'm going to call my vector store that I created up here. And I'm going to say vector store.add texts. And here I'm just going to pass in an array of texts that I want to import. So this is just going to take my texts like that. Now, before I run this, I want to show you something real quick. Remember that I told you that inside a collection, you can have several vectors. In this case, we have if we go back to the documentation, we can see that there is this option to list all the collections that we have, and also we can get information about a certain collection. So we send a GET request to collections endpoint and then the name of our collection. So if I come back here to my collections in my HTTP client, and I say that I want information about this collection right here, and I click on send, you can see that I currently have 0 vectors in my collection, okay? Which makes sense because I just created my collection a few moments ago. But now, after I run this vector store add text, this is going to add those vectors to my collection, okay? So now let's see how that works. Now if I run this, if I don't have any errors, there you go. Now my vectors have been added to my vector store. And now if I go back to here and I send this again, you can see that my vector store count is now 5 because they have been added to my vector database. Now, it doesn't matter if I refresh this or if I or if I close the application or open it again, I will still have these 5 vectors in my vector database. And all I will have to do is to connect to my database and to fetch these vectors in order to perform my querying from my language model. Okay, so let me just do that right now. Great. So now we have successfully added the vectors to our vector store. And this basically means that we now have a persistent database in the cloud that we can, as you can see, we just got all the vector stores from a different program. Like, this is not connected to this notebook, which means that my vectors are actually stored in the cloud, and I can fetch them from whichever application I want, as long as I have the credentials. This means that I don't have to recreate my embeddings every time I want to use them. I can just connect to my database and then just fetch them and perform my computations. And that's what we're going to be doing right now. Right now, it is time to actually connect this vector store to our application and start querying it with user questions so that we can actually start chatting with our story that we uploaded to our database. So let's do that right now. So first of all, I'm going to have to create a question and answer chain from Langchain. Okay, so let me just show you how that works. If I go to Langchain and I go to usage cases, and I come right here to Q&A over documents, context aware, there you go. So here, this is basically what we're going to be doing. We're going to be creating a question and answer chain that is going to retrieve the information from our vector store, and it's going to feed it to a language model so that we can actually chat with our information. So let's do that right now. So let me just title this cell plug vector store into retrieval chain. And this retrieval chain, you will be able to use it inside your application. So first of all, I'm going to say that from Langchain.chains, chains, we're going to import the retrieval QA chain, which is going to allow us to ask questions about a document. And then also from Langchain.llms, I'm going to import OpenAI because I'm just going to be using OpenAI's language models. Okay, and I just need to create a QA object from my retrieval QA class, and this one, we're going to create it from chain type. Let's see, from chain type. There you go. And this one actually takes a few parameters. The first one is the language model that we're going to be using. And in this case, we're just going to be using OpenAI's, like that. I think that by default, if I'm not mistaken, we get callbacks, model name. I think by default it's ChatGPT Turbo 3.5. I think so. I'm not sure, but yeah, you can also add some parameters here if you want to tweak it a little bit more. But I'm just going to go real fast on that. Then the chain type, you're going to type it to stuff, and then you're gonna have to set the retriever, which is going to be the place where you're going to get the information that you want to query from. This means that it's your vector store. Okay, so the retriever is going to be the vector store that we initialized before, vector store, and this one has to be as retriever, like this. There you go. And we run this, and basically what we have done is we have created our chain that we're going to be able to query about the information that is inside our database. Okay, so now what I'm going to do, let's just query it real quick. I'm going to ask a question. Let's say, how many friends are there and what are their names. Okay, and then the response is just going to be my Q&A object. I'm going to say run. I'm going to run my query, and then let's just print my response. If I'm not mistaken, this should print a response related to my story. There are 3 friends, Emily, Ben, and Sarah. And there you go. Apparently, from my text, here are 3 friends indeed, Emily, Ben, and Sarah. So there you go. We have successfully connected our application to Qdrant's hosted database in the cloud. Okay, just to be sure that you understand what happened right here. Remember that we basically created our client, created our collection that we didn't have before. Then we created our vector store. And it is inside this vector store that we added new vectors. And then we connected that vector store to a retrieval chain, which is the one that we use to actually query the text, okay? That to actually use in some sort of chat. However, this cell right here that added the vectors to our vector store is not needed if we already had vectors in the database. This means that since our database is persistent in the cloud, if I reload the application, I will already have my text from the story. I will not need to re-add the documents to my vector store, okay? And that is exactly what we wanted to achieve. Let me show you real quick how to do this in some sort of graphical user interface, so that you can see a little bit in a little bit more real scenario. Let's do that right now. All right, so really quick, let me just tour you around how to use what we just saw into an actual application, okay? In a previous video, we had developed an application that looked something like this, but we had to import a PDF file in order to be able to actually ask questions to it, because we had to ask questions about the PDF file that we were going to upload. In this case, I just stripped it down into its bare minimum. It's just an input text. And the idea is that we're going to have it connect to our remote database that we just created. And we're going to be able to fetch information from there and ask questions to our remote database about the story that we just embedded without actually doing the embeddings again every time we reload the application. Okay, so let's do that. If you want to see how to set up Python project, you can check out the video I did especially about that. But in this case, I just already set this up with this user interface right here. The idea is that we have our load.tnv so that we can load our environment variables. Then we have a simple header and then just our text input. And all of this, I built it using Streamlit, which is a graphical user interface library that allows us to create user interfaces very, very quick and very, very beautiful. So there we go. Now what we're going to want to do is, since we have our user question right here, we're going to want to do something whenever our user submits a question, okay? So I'm just going to copy this right here from here. Let's say, so if my user question is, if we find that we have a user question, we're going to write the user question, and then we're going to use a Q&A chain and run it to compute the answer, okay? And this is going to use our remote database. And so in order to do that, we're going to have to first create our chain, and we're going to use the code that we had right here. Retrieval chain, there you go. There you go. There you go. So we create the chain like this. We're going to have to import all the things that we imported before, which are these two. I'm going to import them up here, and we imported all of this up here too. There you go. And then we're going to have to create our API, our environment variables. We have qhost, Qdrant host, API key, collection name, and OpenAI API key. I have them set up conveniently before so that we can do this pretty quick. There you go. This is exactly the same information that I had in the notebook. Okay, so there you go. We save this. We have this right here. We are creating the chain as we did right here. But what were we doing before? We had to create the client. We're not creating the collection because the collection already exists, because we're dealing with a database that we already created. But we create the client, then we create our vector store, and then we connect that to our chain. So let's do that. First of all, let's just create a function right here that is going to get the vector store. So vector store equals get vector store. Then we just create a function that gets the vector store. And in this function, basically all that we are going to do is we are going to copy the code that we had in here. So first of all, we're going to want to create our client. There you go. Then this client, we're going to want to use it to not create a collection, but we're going to want to create a vector store using the embeddings from OpenAI, like this. There you go, like that. Then what do we do next? We return the vector store. We return the vector store. There you go. So now basically what we're doing, creating the client, embeddings, and the vector store, returning the vector store. We're fetching the vector store here. Create vector store, and then we are connecting it to a Q&A chain, sorry. So there you go. This is basically all that we're doing, and this is basically all that you're going to have to do if you want to connect to a remote database. So now if I save this, and I think that's all, if I'm not mistaken, I'm just going to rerun my Streamlit application. Then if I go right here and I refresh and I say, what are the names of the friends? And then it's supposed to run it. The names of the friends are Emily, Ben, and Sarah, which comes from the text right here that we embedded and we saved in the notebook. So as you can see, we didn't embed it or saved it inside this application. We're just accessing the Qdrant database right here. And as you can see, our cluster actually has this disk usage of 0.001 gigabytes, which of course it's just 5 vectors. But yeah, so I hope this was useful. Here you can see I'll going to be putting this up on GitHub so that you can check it. And yeah, now you know how to connect your application to persistent databases in the cloud using Qdrant, which is a very, very neat substitute for Pinecone if you find that it's too expensive. And their free tier 1 gigabyte free forever cluster is very, very good if you want to try some things out and just experiment with LLM applications. Okay, so I hope this was useful to you, and subscribe if you want more videos like this, and I will see you next time.